Can you tell us how an induction motor starts?
Hello everyone, this video is about a DC motor. So after this video you should be able to define electric motor, draw the diagram of the motor and explain the working of a DC motor. So this is a picture of a simple motor which is made out of just wire, magnet and a battery. Motor is a device to convert electrical energy into mechanical energy. Out here you can see we are giving the electrical energy from here and this fan is rotating. That means we are getting the mechanical energy. Now let's see the video on working of this motor. So this is how a motor works. You can see this circular coil rotates in a magnetic field. The working principle. So when we have a current carrying conductor in a magnetic field, it experiences a force according to Fleming's left hand rule, and we use this concept to make an electric motor. So working principle is force on a current carrying conductor in a magnetic field. So suppose we have a rectangular coil, and to mark this point I am using a different color. So now I am sending the current through it. Next we'll consider only this two wire and current flowing through them. So next I'll keep this in a magnetic field. So magnetic field goes from north to south. So I'll use Fleming's left hand rule out here. So magnetic field is going towards the right. So field is going towards the right. Current is coming out of the plane of the screen. So there will be force in upward direction. And in this conductor, magnetic field is going in this direction from north to south. Current is going into the plane of the screen, so there will be force in downward direction. So out here I have not considered this conductor and this conductor because you already know if the current and magnetic field is not perpendicular, there will be no force. So there will be no force on this conductor. So as we have seen, this force will try to take this conductor upward and this force will try to bring this conductor downward. So there will be a rotating force which will rotate the coil in this direction. So after the half rotation, this part which we have marked that side has come to this side. So now again we'll use the Fleming's left hand rule. So now the current in this conductor is coming out of the screen, so the force is in upward direction. Similarly, the force on this conductor will be in downward direction. So now again this coil will go back to the same position like this. So but the problem out here is it is not rotating through a full circle. It is going to this part and again coming back to this part. So but we don't need this to come back. We want this conductor to rotate so that it can be used in motor. In this video you will see what happens to the conductor when we keep in the magnetic field. So you can see it is not rotating, it is just oscillating from one point to another point. But in our motor the coil was rotating fully, so we have to take care of this problem. Now let's see the problem again. We had one rectangular coil and when there was a current, it rotates and this part comes to this side like this. So after this, if you use the Fleming's rule, then the force will be in upward direction, so it will go back to this position. But we don't want this force to go in upward direction, we want this force to be in downward direction. So we have to change the direction of this force. So there is one way to change the direction of force, which we already know. The direction of force is reversed when the direction of current through the conductor is reversed. If I can change the direction of current when this conductor reaches out here, then the direction of force changes. As you can see right now, current is coming in downward direction. Now if you make it in upward direction, the direction of force also changes. So in order to rotate the coil fully, we need to change the direction of current after each half rotation. And we have one more problem with this coil. So if you connect the coil like this and if you rotate the coil, then the wire out here get twisted and the wire may get snapped. So we have to take care of this problem also. To solve this problem, we use commutator. Commutator helps in reversing the direction of current after each half rotation, and we use carbon brush to connect the rotating coil with the circuit so that the wire don't get twisted. So let's see the picture. So this is a simple picture of a DC motor. This is the coil which we are talking about, and these C-shaped rings are called commutator, and this commutator is connected with this coil, and this commutator can rotate with this coil, and these two blocks are carbon brushes, and they helps in making the contact between this rotating part and the outer circuit so that the commutator can rotate, and at the same time it gets the electric current also. So from this picture we can understand the function of commutator, and another name for commutator is split ring because it is a ring which is cut from the middle. And out here you can see at this part of the conductor current is going towards the negative side, and from this part of the conductor current is coming out from the positive side. So when this conductor AB comes to this side, it comes in contact with X, and the current in AB will flow in downward direction. So after half rotation, when this AB come to this side, so this P will come to this side. It will touch the part of the circuit in which current is flowing in upward direction. So after each half rotation, the direction of current is changed. Now let's understand this one more time using this picture. So out here you can see AB is in this side and current is flowing in downward direction and force is in upward direction. So after the half rotation, AB will come to this side and the current in AB will be in upward direction. See out here it is in downward direction because it is touching this part. Now after half rotation it will come to this side and this P will come to this side, and the current in P will be in upward direction. So with the help of commutator, the direction of current is reversed after each half rotation. Let's see the video to understand this. So this is a commutator or split ring. So we have two C-like structure. In between there is a cut, and these are the brushes. Now you can see this can rotate also, and at the same time these brushes make the contact so that current can flow through the coil. Now from here you can see right now this conductor is touching this part, positive side of the battery. When this makes one rotation, then this will come to this side, that means it will touch the negative side, so the direction of current changes automatically. So now if you use Fleming's left hand rule, so force on this side will be in upward direction and force on this side will be in downward direction, so the coil will rotate like this. Now you can see right now current out here is moving in one direction because this is touching this wire. So after some time, so now this wire is touching this wire, so after each half rotation the direction of current will change and the direction of force will change. Now this is another video. You can see out here the current is in this direction and force is in downward direction. So after the rotation, see the direction of current changes. Out here it's going in this direction and the force also changes. Right now current is coming in downward direction. Now after this it will be in another direction. So this is how a commutator and carbon brush helps in changing the direction of current and direction of force so that the coil rotates fully. But there is a problem with one coil. So if you use one coil, then the rotation will not be smooth. So in order to make this smooth rotation, we can make use of many coils. So you can see it is not running smoothly. So now if you use 2 coils, then it runs smoothly. Now you can see it is running smoother than previous one. And if you use more coils, then it will move very smoothly. So you can see there are many coils and many commutators. To make the magnetic field strong, we can use a frame of soft iron, and this frame is called armature. To make the magnetic field strong, we can replace the permanent magnet by an electromagnet. So out here you can see this is the iron, and instead of magnet we are using the electromagnet, which can produce strong magnetic field. So this is about the electric motor and its working. At first the force on AB is in upward direction and the force on DC is in downward direction, but when it completes the half rotation, the direction of current changes due to the effect of commutator, and the direction of force also changes. That means the force on AB will be in downward direction, so the coils keeps on rotating. So you can pause the video and copy the working. So to make the motor strong, we can use many coils. Instead of one coils, we can use many coils, we have seen in the video. And we may use soft iron frame to make the magnetic field strong, and we can replace the permanent magnet by electromagnet, because electromagnet can produce strong magnetic field. So out here in the picture you can see this is a very strong motor. We call it industrial motor. So the electric motor is used in all the appliances which is capable of rotating, like this toy, this drilling machine, washing machine, and electric fan also make use of electric motor. So now let's summarize the video. A DC motor converts electrical energy into mechanical energy, and we are saying this to be a DC motor because it make use of direct current, not alternating current. So DC means direct current motor, and it works on the principle of force on a current carrying conductor. And this is a picture of a motor, and this commutators helps in changing the direction of current after each half rotation, so that the coil can rotate fully, and brush helps in making the contact between the external circuit and the internal circuit. And the motor has many applications like water pump, fan, washing machine, mixture, etc. So I think this is the end of the video. Don't forget to like the video and subscribe the channel. Thank you.